Okay, find the limit. As x approaches 0, 1 over x squared. Well, if you look at the graph of this, I mean, this is an inverse variation, right? And we know what inverse variations look like. If it's just 1 over x, it has this shape, like that and like that. The fact that it's 1 over x squared just means it'll be here and here, because it'll always be positive. Right. Now, looking at that picture, as x approaches 0 from the left, what's going on with the value of the function? It's going towards infinity. If x approaches 0 from the right, it's going to positive infinity. Remember that part of the definition. L is a fixed number. Infinity is not a fixed number. This one has no limit. Right? It cannot be approaching infinity or negative infinity. So no limit. Right? Approaches infinity. Not a fixed number. L. So there's actually 3 scenarios that do not have limits. Okay. The first is like the example 6, where you're approaching a different number from the left and the right. The second is it's going towards infinity or negative infinity, right? It's not going to, it's increasing or decreasing without bound is the way the book puts it. That's like example 7 that we just saw. And the third, you kind of have to work hard to make it seem like it, but if you look at example 8, the function is doing this it's kind of like a sine. It just says it gets closer and closer to 0, it's just going infinitely up and down, up and down, up and down. That's called oscillating. Right? If it's oscillating as it goes closer and closer to the C, then there is no limit. That one's kind of a hard one to look at. If you look in the book, you know, when they're coming in from the sides, you know, the wavelength is a little longer, and then it gets shorter and shorter and shorter until it's almost like black in here. You know, it's just so concentrated because it's just bouncing up and down and up and down.